All right, can everyone see my screen?
Absolutely. You
All
have the
right,
floor.
perfect. Cool. My name is Daniel Feldman, and I worked with Ilya on this talk, although he's not online right now. It's the middle of the night for him. And the title is Attesting, Authenticating, and Authorizing NSM Components with SPIRE. This is a little bit of a different talk because this functionality is mostly already implemented in NSM. So we'll be talking about how it's already implemented and then what the next steps are for the future. And honestly, I'm a newbie to NSM. I've done all the examples in the repo and learned as much as I could, but Ilya is the expert, and he actually implemented SPIRE inside NSM. I work on the SPIRE project, so that's my background. So what we're going to be talking about today is service identity problems in general, and why we developed SPIFFE and SPIRE, sort of in a general sense, as a security tool for a variety of different applications. We're going to walk through how the protocol works, then how it's applied in NSM, and then the last subject is how do we get SPIRE really working for NSM interdomain, which is something that there are ways to do now, but we can make a lot better. So service identity problems in general. So you've got a Kubernetes cluster. It's running some services. Let's say they're NSM services, but they could be any other services. How do we keep hackers out? How do we keep accidental deployments from sending tons of test traffic or dev traffic to production services and messing them up? How do we prevent accidentally leaving our doors unlocked, having an ingress that is open to the public that shouldn't be? How do we make sure that none of our images or code are, have backdoors in them? There are all these different security problems, and service identity means assigning an identity, a unique identity to each service to be able to prevent these problems from occurring. So one way to do it, sort of the default way to do it in Kubernetes, is to use service account tokens, which are just JWT tokens that you can get out of Kubernetes really easily. They're just JWT tokens. Oh, sorry. So they can be stolen really easily. And also there's no obvious way to use a JWT token to set up a TLS connection. You can do it if you really want to, but it's a little bit complicated. But other than that, you could use service account tokens to make sure that each service is who it says it is. It's just a little bit clunky, and it's really tightly tied into Kubernetes APIs, which we might not want if we want to communicate with things outside Kubernetes. Can we use Web PKI to give everything an identity? The answer is no. In Web PKI, you're basically tying a website or a service very tightly to DNS so that you can prove that that website has that DNS address. And services, internal services like NSM services or some companies' internal services generally don't have well-defined host names. They might have lots of copies of a service, or they might not have DNS set up at all yet, maybe when you're initializing a cluster. Also, when a service is starting up, how would it know what its DNS identity is? So you could make Web PKI work for service identity. It's just really clunky and complicated, and I haven't actually seen it done, but this is usually the first question people ask when you say, I want to secure all these connections between different servers. Can we just do it the same way it's done on the web? And the usual answer is no, at least not easily. So what most companies are doing for their microservice infrastructure, most SaaS products or websites or whatever, they're using a secret store. They're using something like HashiCorp Vault, or there's a bunch of competitors to HashiCorp Vault. You authenticate into it and you get some secrets, and then you use those secrets to talk from one service to another service, usually just a JWT token or even just a string token. And this is actually probably fine for like a corporate network if you are sure that you can rotate your credentials regularly and make sure that they're not being misused, all that. For something like NSM, which is a product that you're deploying in lots of different places, obviously you can't really guarantee that the people who are installing and running NSM can do that. So those are a couple of different things we really can't do. We can't easily use service account tokens to do service identity. We can't really do Web PKI for service identity. We can't really do secret stores for service identity. So what can we do? Well, that's where the SPIFFE and SPIRE projects come in. So these are both CNCF top-level projects. They're both in the incubation phase. So we're sort of going along the CNCF pipeline where you start as a sandbox project, then you get to an incubation phase, and then you get to a graduated project. SPIFFE is the standards project where we're just trying to standardize a way to do service identity. And SPIRE is the actual implementation of the standard. So it's two separate projects. Well, we're hoping that there will be more implementations of SPIFFE in all kinds of different CNCF projects. It is starting to happen, but so far the only real implementation, the only real complete implementation is SPIRE. So SPIFFE includes a couple of different parts. These are the parts of the standard. So first of all, we specified a way to make SPIFFE IDs, which is a standard format for your service identity. It looks like a URL. So SPIFFE://, then there's a trust domain identifier, then a slash, then some kind of text identifier for your service. So that's pretty straightforward. Then we have SVIDs, which are cryptographically verifiable documents that assert a specific SPIFFE ID. So why do I say cryptographically verifiable documents? We're not inventing our own format here. We support either X509 certificates or JOT certificate or JOT tokens with specific fields filled in and certain supported configurations in terms of cipher suites and all that. So there's a way to assert your SPIFFE ID in a way that's verifiable by every party in the system. Trust bundles, which again, it's a format for your root certificates for your system. So you can verify all these SPIFFE verifiable identity documents. And then the last component of the SPIFFE standard is this thing called the Workload API, which is it's a local API. It's based on gRPC for your workloads to obtain a SPIFFE ID, an SVID, and a trust bundle. And if why is it a local API is the first question people usually have. Well, if it was a remote API, you'd need some way to authenticate it. And since we're trying to solve the authentication problem, it needs to be a local API. So your workload connects to this local address running on the same node. And then whatever is implementing SPIFFE uses the operating system features to verify the process that's calling that API and give it the right SPIFFE ID, the right SVID, and the right trust bundles. And then that workload can use them to communicate. So we're not implementing a service mesh. We don't get involved in the data plane at all. All we're doing is giving things an identity. So here's, this is just an X509 SVID. This is just a dump from OpenSSL. And you can see exactly what is a little bit unusual here, which is that in this X509 subject alternative name field, that's where we put the SPIFFE ID. And other than that, it's a completely standard X509 certificate. The only difference is that one field is filled in with the SPIFFE ID. So we're sort of misusing an existing field for a different purpose. And other than that, it's completely compatible with all your usual TLS libraries. You can use it to initiate connections. You can use it within proxies. You can use it within web servers. You just need to maintain that, that one field. So how do we start up a SPIRE system? Well, first of all, you have a SPIRE server. And in a typical, like a corporate SaaS environment, the SPIRE server would be running on maybe separate hardware, maybe some kind of trusted environment that only a few people have access to. For NSM, it's running on the same Kubernetes cluster as everything else, which makes sense for the threat models that NSM faces. Because if someone can get into your Kubernetes cluster that's running NSM, they already have access to all your data anyway. So it doesn't matter. But in a company that maybe has 1,000 developers with access to Kubernetes, you want to keep your SPIRE server separate because that's signing certificates that everyone else has access to. So you start up SPIRE. And then you install these SPIRE agents. They're running as a Kubernetes daemon set on each node. And the first step is something called node attestation. So we have to authenticate each SPIRE agent to the SPIRE server and the SPIRE server to each SPIRE agent. And I'll go into how that works in a minute. It's not any kind of big mystery. You can use a join token. So you're basically just copying and pasting a string. You can use Kubernetes features to automatically do this, which is what you do in NSM because it's always running inside Kubernetes. There's a couple different options there. Then once you have the SPIRE agent authenticated to the SPIRE server, you can set up workloads, and each workload is talking to the SPIRE agent. The SPIRE agent is talking to your operating system, verifying the identity of that workload and giving it the right SPIFFE ID, the right trust bundle, the right SVID. And it can talk to the Kubernetes API, make sure that it has the right image, make sure that it has the right pod name, make sure that it has the right service account name before doing that. Then once everything has an identity, either a JOT SVID or an X509 SVID, then those workloads can establish secure communication between each other. And again, we don't actually tell you how to establish the secure communication. You can do that with TLS gRPC, which is what NSM is doing. But you could also use any protocol you want that you have some way to use those identities for. So I did a little more detail on how the node attestation setup works. So this is how the SPIRE agent gets its identity. The first step is, first of all, you need that trust bundle initially, because otherwise the agent would have no way to trust the SPIRE server. So you have a trust bundle that's stored somewhere in NSM. It's in a Kubernetes config map, but we also support all kinds of other configurations. You can have it in S3, you can have it on just in a file on disk. So you fetch the root certificates. Then the SPIRE agent talks to the SPIRE server and requests its own node identity. Assuming you're running on Kubernetes, the agent requests its identity from Kubernetes. It gets a signed node identity. So for Kubernetes, it's a service account token, which is cryptographically verifiable. It sends that identity over to the SPIRE server. The SPIRE server verifies the signature. And then repeatedly over time, the SPIRE agent is sending a CSR, is sending a CSR to the SPIRE server. The SPIRE server is signing that CSR and sending back a signed SVID and a trust bundle. And that happens very frequently, typically every few minutes. It's at least checking if the SVID needs to be refreshed. And in our standard configuration, the SVID is refreshed every 4 hours. So these aren't long-lived credentials. They're refreshed really frequently. Usually don't need to have ever revoke them because they're just going to expire on their own really quickly. And then workload attestation. This is the step where the SPIRE agent figures out who's talking to the SPIRE agent to get the SVID that's actually used for communication between services. So first you need some configuration. You need something called a registration entry, and I'll go into that in a second. But that contains sort of instructions for the SPIRE server on which workload should get which identity. And then again, repeatedly over time, the agent is connecting over to the SPIRE server, and it gets a list of the registration entries. It makes up some CSRs. The server signs those CSRs, and then the server sends back SVIDs. And then frequently, again, every few minutes, the workload gets new SVIDs, and that's updated through a gRPC API running over a local socket. And again, it needs to be a local socket because the workload has to be able to identify itself to the SPIRE agent in a secure way. So we use features of the OS kernel to verify the process ID, the group ID, the binary that's running in order to give it the right SVIDs. So where do these registration entries come from? So again, the first step in configuring all this is you need these registration entries. in a typical, like a SaaS company that's running 1,000 different services, you'd probably have some security team managing all the registration entries. For NSM, because it's a prepackaged product, that obviously doesn't work. So instead, there's a sidecar proxy, or sorry, just a sidecar called NSM SPIRE that takes a bunch of JSON registration entries and just loads them into SPIRE every time that NSM starts up. And you can find these registration entries. They're in a JSON file that's checked into the Helm chart for NSM. And all it's doing is it's assigning a SPIFFE ID. So this SPIFFE ID, oh, that's actually for SPIRE itself. But here's the SPIFFE ID for NS Manager. It's assigning the SPIFFE ID NS Manager to the Kubernetes service account NS Manager account. So any service that's running under that service account can get this SPIFFE ID. That's all it's doing. And this is a really cool way of doing it, loading the registration entries in from a JSON file automatically. Again, most of our users are, maybe at a company where there might be hundreds or thousands of services, and there's someone sitting around managing these registration entries for all those services. But because NSM is a prepackaged product, they're just stored in a flat file and loaded in. Now, interdomain is where it gets really interesting. Obviously, NSM needs interdomain to really be useful, and this is still in the early stages for SPIFFE. In a typical company, again, a company that would just have one big SPIRE server, they might have 10 different Kubernetes clusters or 100 different Kubernetes clusters, all talking to one SPIRE server that's sitting in a server in their data center somewhere, or sitting in one enclave on the cloud. So they don't need federation quite as much between different domains. For NSM, because the entire point of NSM is to establish network communication between different Kubernetes clusters, you really need federation between multiple SPIRE domains. So you would have one SPIRE running in each Kubernetes cluster, presumably, in a typical NSM setup. And federation between SPIRE domains, we do have it working. We actually have a couple different methods. We don't have a whole lot of documentation on how to do this, and configuring it is still a little bit complicated. For the NSM examples and the tests that are checked into the NSM repository, they're actually using a little Go proxy that just provides a SPIFFE certificate, sort of going around the node attestation API and the workload attestation API, which is a really clever way of doing it. But in the long term, what we really want is either two different SPIRE servers exchanging their trust bundles frequently, so they're basically federating independently on their own, and then each SPIRE server would provide SPIFFE certificates to all the services running in its Kubernetes cluster, and then they'd be trading bundles, so they'd each trust each other's certificates. Or another approach that is sort of complementary would be having an upstream SPIRE server that's signing root certificates for two other SPIRE servers, and each SPIRE server is providing certificates for everything in its Kubernetes clusters. And then because they'd all use the same root certificate, they'd all be able to trust each other. So again, this is still a little bit of a work in progress. It's really important for NSM, and we understand that. It's for a typical company that's just got one SPIRE server or one cluster of SPIRE servers, it's probably less important because they don't necessarily need to establish these federation relationships. So the ongoing work that I'm working on, and that the whole SPIRE team is working on, we just finished a big project where we refactored all these APIs, made them a lot cleaner, a lot easier to understand. Improving federation is a top priority, like I just said. Improving JOT support. So we do support using JOT tokens as a SPIFFE identity document, but it's not exactly documented very well, and we're going to do a lot of cleanup in that area. Transitive identity is a huge project that a lot of people are working on, including some people from the NSM project, but that's basically using a separate identity from some other system and passing it through SPIFFE identity. So I can verify that my name is Daniel and I am using SPIFFE service X and pass my identity as Daniel through the SPIFFE identity in a verifiable way. So that's a huge area of sort of ongoing work. Another thing that isn't on here that we're working on is federation with OIDC identity providers. So you'd be able to use your SPIFFE identity in order to connect to, say, the AWS API. And that's actually pretty much working, but again, the documentation is a little bit lacking and it's a little bit clunky to configure. So that's just about 25 minutes. Thank you very much. Here's all my contact information, dan.feldman@hp.com, Twitter, Ilya. You can follow up with him on some of the details since he did a lot of the implementation of SPIRE within NSM. We've got some other talks on SPIRE on the Kubernetes KubeCon maintainer track. They're actually both tomorrow, and you can look on the schedule and get the time in your local time zone. I'm doing one, and then Andrew Harding is doing maybe a more advanced SPIRE session that might be really useful if you want to get more into the details of how SPIRE works. We're on the NSM Slack. There's also a SPIFFE Slack channel. And I guess we have some time for questions. So it looks like I got a couple questions on Slack, which isn't coming up for me right away. Sorry. Where'd my Slack window go? Okay. So we had a question, is Istio SPIFFE compliant? And the answer is they're working on it. And that's why I said it's sort of work in progress, getting more different service meshes to adopt SPIFFE. It is not fully compliant yet. It doesn't support the Workload API. And we have proposals out to them to implement the Workload API, basically. Next question is, can we point to documentation on SPIRE Federation? I will follow up offline on that. We have some stuff in progress. I actually wrote a blog post about a year ago on how SPIFFE Federation worked, but that's a little bit out of date. That was a year ago. Like every open source project that's changing very fast, the documentation is always a work in progress. Are there any questions on the Zoom session?